In this video, I'm going to show you how to solve for Model 6 Challenge Lab, that is, creating a VPC networking environment for the cafe. So by the end of this video, you should be able to get 56 out of 56, okay? So let's get right to it. So with Model 6 Challenge Lab is creating a VPC networking environment for the cafe. So I'm going to uncheck the terminal so that we will see the instructions very well. Okay. Alright, so I'm going to skip the scenario and then move on to the lab objective. So the objective of this lab is to use Amazon VPC to create a networking environment on AWS and then implement security layers to protect our resources. So by the end of this lab, we should be able to create a VPC environment that enables us to securely connect to the private resources, and then also we should be able to enable our private resources to connect to the internet, and then we should be able to create an additional layer of security in our VPC to control traffic to and from private resources, right? So by the end of this lab, this is how our architecture is going to look like. Okay, this is how our architecture is going to look like. We set up an internet gateway, and then in the public subnet we will set up a bastion host and then a test instance in the public subnet, and in the private subnet we will set up the EC2 instance. Okay, so let's get right to the instructions. To start the lab, just click on start lab here and then it will start. So my lab is starting here, as you can see here. All right, so the first challenge is that you should create a VPC network that allows the cafe staff to remotely and securely administer the web application server. So in this challenge, we will take on the role of the cafe systems administrators, and then we will create and configure a VPC network so that we can securely connect from a bastion host in the public subnet to an EC2 instance in a private subnet. We will also create a NAT gateway to enable the EC2 instance in our private subnet to access the internet, right? So let's look at it. So the lab has started already. So to open the AWS management console, just click on AWS here and it will open it and automatically sign us in here. So when this happens, click here and then close it, and then click on AWS again and it will automatically sign you in to the AWS management console. Yeah. So let's look at the task one. So creating a public subnet. So your first task in this lab is to create a public subnet in the lab VPC. So after we create a public subnet, we will create an internet gateway to allow communication from the subnet to the internet. Alright. So we also update the routing table that's attached to the subnet to the route internet bound network traffic through the internet gateway. So you'll be asked to open the Amazon VPC console, and then we should note that there is a lab called lab VPC that has been already created for us. Alright, so let's open the VPC console. If you don't find it here, we search it here, VPC, and then let's open the VPC. And we should note that, okay, so we should create a public subnet that meets the following criteria. So after we note the lab VPC, we will create a public subnet. Alright, so let's first note the VPC. So you can either click here or click on your VPCs, right? So let's click on this one. And yes, we can see that we have a lab VPC for us, right? So what we have to do is to create a public subnet with the name tag public subnet, and in the lab VPC, and then the availability zone should be the first availability zone. Alright, so let's click on subnet, create subnet, and then it should be in the lab VPC. Let's scroll down, then the subnet name should be the public subnet, then the availability zone should be the first availability zone, and then the IPv4 subnet CIDR block should be this, right? So let's copy this. Let's copy that exact thing and then paste it here. Alright, so let's create the subnet. Right, so we created the public subnet. So let's look at the next thing to do. Create a new internet gateway and attach it to the lab VPC. So to do that, let's scroll down and then click on internet gateways, and then let's create an internet gateway. Alright, so with the name tag, let's say you name it Cafe Internet Gateway, and then you will create the internet gateway, and then you can either click on attach to a VPC, or let's go to actions and then attach to VPC. And which VPC are we attaching to? The lab VPC, right? Then attach internet gateway. Alright, so edit the route table that was created in your VPC, and then add this route for the target select internet gateway. Alright, so we have to edit the route table. So to do that, let's go to route tables, and then notice the lab VPC. Okay, you can see that is here, right? So we can choose to rename this with, let's say, public route table, so that we can either so that you can simply notice it. Okay, so is this one? You can see lab here, right? That is the lab VPC. So they said we should edit the route and then assign this IP address to it, right? And then the target should be internet gateway. So let's go to route, scroll down and then edit routes, and then add routes, and this one we select this one, right? And then it should be internet gateway, and we should assign it to the internet gateway which we just created, and then save the changes. Alright, so we've done this. So creating a bastion host. So in this task, you will create a bastion host in the public subnet. So we are creating the bastion host in the public subnet. Alright, so from the EC2 console, create an instance in a public subnet, and the instance name should be bastion host. Okay, so let's copy the instance name. So to open the EC2 console, let's duplicate this tab, and then open the EC2 console in this console, right? So let's type EC2, and then and then click on the EC2 here, and then we have to create a new instance. So to create a new instance, you can launch the instance here, or let's check an instances that are already running, and we don't have any instance that is running. So let's launch the instance, and then the instance name should be the bastion host. Let's scroll down. Then we should maintain the Amazon Linux AMI, and then the instance type should be T2 micro, and the auto assign public IP should be disabled. So Amazon Linux AMI here, T2 micro here. The key pair, they say the key pair should be bulky. Alright, so the key pair should be bulky. Let's select it, and then expand, edit the network settings, and then assign it to the lab VPC. With the subnet, they said we should create it in a public subnet, right? Here in a public subnet. So the subnet should be public subnet here, and then the auto assign public IP should be disabled. Alright, so with the security group, we are to create a new security group. So let's select the security group name, and then paste it here, bastion host security group, and then we can choose to for the description you can use any description. So let me use the same name here. Alright, so what are we to configure again? Then they said the type should be SSH port 22, and then the source should be our IP address. So SSH TCP port 22, and then this should be our IP address. Alright, yeah, so I think that's all. Okay, so let's launch the instance. Scroll down, launch instance. and then our instance will be launching. So let's look at the next task as we are waiting for the instance to finish launching. Alright, so allocating an elastic IP address for the Bastion host. Alright, so we have to allocate an IP address for the Bastion host. Alright, so that is what we've been asked to do. So let's see if the instance is finished launching. Um, let's wait for the instance to finish launching, and then we'll look at the next task. It wouldn't take time, so alright, so we've launched the instance. So let's scroll down and then view all instances. Alright, so this is the Bastion host instance, right? It is running. So let's click on it, and you can see that when you go to networking, you can see that there's no public IPv4 address assigned to it. Okay, so that is what we've been asked to do here, right? Allocating an elastic IP address for the Bastion host. So to do that, let's scroll down here, then select elastic IPs, and then allocate IP address. Scroll down and then allocate it. Okay, so let's select that particular IP address and then go to action, associate elastic IP address. Let's scroll down and then which instance, the Bastion host, right? Okay, and then when you are done, associate the elastic IP address. Okay, so now when you go to the instances and then select the Bastion host, let's refresh it. You see that we now have a public IPv4 address here. Alright. Okay, great. So right now we've allocated an elastic IP address. Okay, and then we've made it reachable from the internet over IPv4 by associating it with our Bastion host. So the task 4 is to test the connection to the Bastion host. So in this task we are going to use SSH key. So for Linux users, you should use the .pem, and then for Windows users, you should use .ppk. So I'm using Windows, so I'm going to use .ppk file. Alright. So on the top right area of the instructions, select details. So here, right, and then we are asked to download the SSH key here. Alright. So let's go to details, show, and then this SSH key. So let's download it. Okay, so we've already downloaded it. Okay, so for Microsoft Windows users, we should download this, we should use this, right? So we are done. So they say we should connect to our Bastion host by using the SSH. So if you don't have PuTTY, you can download PuTTY, right? For Microsoft users, I've already downloaded PuTTY on my machine, so I will just search PuTTY. And you can see it here. I will click on it, and it will open for us. So the host name should be our IP address we just allocated, right? So let's copy it here, go to PuTTY, and then paste the host name, right? So the host name should be the IP address here. All right, great. So let's see what else to do. Okay, so we've done that. We've connected it by pasting the IP address. So let's move on. After you have tested your connection to the Bastion host, you can close the terminal or the PuTTY. So let's move on to the next. We are going to utilize the PuTTY again. So let's leave the tab open. So let's go down. If you don't have the PuTTY, you can download it with this link. And then they said we should set the seconds between keep alive to 30 seconds. So to do that, go to PuTTY again, go to connection, and then so the seconds between the keep alive has been set to 30 seconds. All right. So let's keep this tab open, and let's click on the side to see task 5, that is creating a private subnet. So in this task we are going to create a private subnet in the lab VPC. So in the console we are going to create a private subnet with name tag private subnet. So let's copy it, To create a subnet, where do you have to go? The VPC. Okay, click on subnet, create subnet. In the lab VPC, scroll down, then the subnet name should be the private subnet. The availability zone should be the same as the public subnet, but then the public IPv4 address should be this. So let's copy the public IPv4 address, go back, the first availability zone, and then let's paste the IPv4 address, the CIDR block, sorry. And then let's create the subnet here. Task 6, creating a NAT gateway. So in this task, we are going to create a NAT gateway which enables resources in the private subnet to connect to the internet. So to create a NAT gateway, we have to meet this criteria. So the name should be lab NAT gateway. Let's copy it. Let's go to the VPC console, scroll down to NAT gateway, click on it, and then create NAT gateway. The name should be lab NAT gateway, and the subnet should be the public subnet. Scroll down, public subnet. All right. So then they said we should, okay, your NAT gateway needs an elastic IP address. So we have to allocate an IP address to it, and then create NAT gateway. Okay. So the 20th point is create a new route table that meets the following criteria. So the name should be private route table. Let's copy that. Let's go back to the VPC console, go to route table, create route table, then the name should be the private lab table associated with the lab VPC. Let's go down and then create the route table. Alright, it said the destination should be this, and then the target should be NAT gateway. So let's go back, go to edit route, add route. The destination should be this, then the target should be NAT gateway. Let's attach it to the lab NAT gateway we just created and save the changes. Okay, so attach this route table to the private subnet. So we have to attach this route table to the private subnet. So let's click on this. To attach it, go to subnet association, edit subnet association, select the private subnet, and then save association. Alright, so task 7, creating an EC2 instance in the private subnet. So in this task, we are going to create an EC2 instance in the private subnet, and then we are going to configure it to allow SSH traffic from the bastion host. So we also create a new key pair to access this instance. Alright, so the new key pair name should be Voki2. Okay, so the instance should meet this criteria, and then the name should be private instance. So let's copy it, go back to the EC2 console, launch a new instance with the name private instance, and then Amazon Linux AMI T2 micro as they are specifying it here. Okay, alright, and then the source should be the bastion host, so don't forget that T2 micro. The key pair is that we are going to create a new key pair name called Voki2. So let's create a new key pair name. If you are using OS or Linux, select this .pem. If you are using Windows, select .ppk. The key pair name should be Voki2. So Voki2. Alright, so let's create the key pair. It will download the key pair for us, right? So let's scroll down with the network settings. Let's go to edit, attach it to the lab VPC. It should be in the private subnet, right? We stated it here, private subnet. Alright, so let's go back. It's in the private subnet, and then They said the source should be the Bastion host security group. Okay, so you have to select existing security group. Then with the existing security group, it should be the Bastion host security group. When we are done, we should launch the instance here. Okay. Task 8, configuring your SSH client for SSH pass-through. So because the private instance we just created uses a different key pair than the Bastion host, we must configure our SSH clients to use SSH pass-through. So this action will allow us to use a key pair that's stored in our computer to access the private instance without uploading the key pair to the Bastion host. So they said this is a good practice. Okay, this is a good security practice. So for Windows users, if you are using Windows, then you can follow this. Since I'm also using Windows, you can follow these instructions. So download and install a Pagent. Okay, so to download the Pagent, click this page. So let's open it as a new tab by right clicking. So you left click and then open as a new tab. Go back and go to the tab and then scroll down to where you see SSH and PuTTY. You see SSH authentication agent and PuTTY. So based on your operating system, you can select the appropriate agent file here. So it's done downloading, so I can click on it and I'm going to see it here. Okay, I'm going to see it here. Alright, so it's done downloading, so I can close this tab. Alright, so after you've installed, open it and then the Pagent runs as a Windows service. Alright, so to import the PuTTY formatted key pair, follow these instructions. So choose add key and then add the bucket 2 key pair. So to do that, go here, double click on this, then add key, add the bucket 2, then open. Alright, so you can click on the side, then your screen should look similar to this example. And yes, you can see that our screen looks similar to that. Let's click on the side, add the first working file, that's the lab user. So we have to add the first working file too. So add key, the lab user.ppk, copy, and let's click on the side. And you should have two keys listed. Alright. So in PuTTY under connection SSH auth, select allow agent forwarding. So in PuTTY under connection SSH, then SSH, then auth, you should allow agent forwarding here. Alright. Okay. So when you are done, they said expand the auth and then choose credentials and upload the lab user ppk file. Open and then choose accept. So let's go back to the PuTTY. Expand this auth, credentials, and then private key file for authentication. Browse. Select this lab user.ppk, then okay, and then open. Accept. To log in as use EC2 user. Alright, EC2 user. Then hit enter, and you see it here. Alright. So let's move on. That is for Microsoft Windows users. So for Microsoft Windows users, you have to skip to task 9, step 32. For Mac operating system users and Linux users, you have to follow these instructions. So since I'm using Windows, I'm going to skip to task 9 as testing the SSH connection from the Bastion host. So in this task, we are going to test the SSH connection from our Bastion host to the EC2 instance that is running in the private subnet. So since you already have the PuTTY here, it said connect to the private instance by using SSH and then IP address for the private instance. So you should select this up to here. Then the rest should be the private IP address for the private subnet. Okay, so let's go back to PuTTY. Paste that here, and then go back to EC2 console. Okay, let's view all instances. You can see the private instance here. Okay, So I'll check this, select the private instance here, go to networking. Sorry, let's do this place. Okay, private instance. Okay, select the private instance, and you can see the private IPv4 address here. So copy it, go back to PuTTY, then paste it here, hit enter. Alright, so this will take time before it runs. Alright, so let's go back to the instructions. Now that you are connected to the EC2 instance in the private subnet, test its connection by using ping this. So copy it, go back to PuTTY, you can paste it here, hit enter. It will take time and then it will run. So let's go back. Let's minimize this. So to exit it, you have to press Ctrl Enter to exit. Okay. So let's give it time to run. So let's continue with the next task. You have now established communication between the person host in the public subnet and the EC2 instance in the private subnet, like the following diagram. Alright. Okay. So challenge 2. Sophia and Nico are proud of the changes we just made to the cafe application architecture. So they are also pleased by the additional security they built, and they are also glad to have a test environment that they can use before they deploy updates to the production instance. So they tell Matthew about their new application architecture, and then he's impressed. To further improve the application security, Matthew advises them to build an additional layer of security by using custom network ACLs. Okay, so in this lab, we are going to continue to take on the role of one of the cafe systems administrators. Then we are going to establish secure access from the person host to EC2 instance in the private subnet, and we must enhance the security layer of the private subnet. So to accomplish this, we have to create and configure a custom network ACL. Okay, that's network access control list, right? So task 10, creating a network ACL. So to do that, let's go back to the instructions. Okay, so go to the Amazon VPC console and then inspect the default network ACL of the lab VPC. The subnet we just created are automatically associated with the default network ACL. Then the inbound rule default is set to allow all traffic. Let's go back to the VPC console. Let's go down to network ACL under security here. And they said we should notice the lab VPC here. So it is still loading. You can close this. Alright. So if this is taking long, we can refresh this page and it will come. Yes, you can see it here. Okay. So the one associated with the lab VPC is this one. You can see it here. Okay. Alright. So they said we should know that the inbound and outbound rules allows all traffic. Let's check. Let's select it here. Inbound rules. Let's see. Yes, it allows all traffic. And then the outbound rules also allows all traffic here. Okay. So we should create a custom network ACL called lab network ACL. So let's copy the name. Go here, create network ACL. The name should be lab network ACL, and the VPC should be the lab VPC, right? So let's create the network ACL. Let's go back to the instructions. And then it said the default inbound and outbound rules of the custom network ACL deny all traffic. Let's see if it's true. This new network ACL, the inbound rules. Let's go down. You can see that it denies the inbound rules, the outbound rules too. Let's scroll down. Yes, it denies it, and that is true. Alright. So configure your custom network ACL to allow all traffic that goes into and out of the private subnet. So of the private subnet. So let's go to the network ACL. Edit. Let's first edit the inbound rules, and we are going to add a rule let's name the rule 100 that allow all traffic. Is it all traffic? Um, that allow all traffic, yes. So let's go back, save changes, and then edit the outbound route. Let's go down, add a rule. Let's name that one to rule 100 that allows all traffic, and then save changes. All right. So we've done that. Okay, so task 11, testing your custom network ACL. So remember that they mentioned that the okay, so let's continue. Create an EC2 instance in the public subnet of the lab VPC. It should meet the following criteria. Okay, so we should create a test instance. Let's copy it. Let's go to the EC2 console, launch a new instance with the name, test instance. Let's scroll down. So the AMI should be a Linux 2023 T2 micro, allows all ICMP IPv4. Okay, so Amazon Linux 2023 T2 micro. The key pair should be bulky. Scroll down, edit the network settings, lab VPC. Should be in the private subnet. Is it the public subnet? Okay, so this should be public subnet. Scroll down. Then for the security group, we can just use test SG. Okay, and then we can use the same thing as the description. Test SG. All right. So they said it should allow all ICMP IPv4. So um, allow all ICMP IPv4. Yes, we've done that here. All right. Okay. So when we are done, let's launch the instance. Scroll down, then launch the instance. So it's launching. So they said we should note the IP address of the test instance. Okay. So test that you can reach the private IP address of the test instance by using ping, then the private IP address of the test instance. So let's see if the instance is done. Okay, so the instance is still launched. So let's go back to PuTTY and then look at the ping that we just did, and we can see that it is running here, right? So to stop it, press Ctrl C to stop it. All right. So let's go back to our EC2 console. Okay, so the instance is done launching. So let's scroll down, view all instances. Okay, let's refresh this to see our test instance. So right now we have our test instance here. All right. So let's select the test instance and then note the IP, the private IP address, which is this one. So we are going to say we should use ping, then the private IP address. So let's go back here, select the IP address, go back to PuTTY, use ping space, then paste the IP here, hit enter, and it is going to run. So let's see, leave the ping utility running. Okay, so we've left that. So modify your custom network ACL to deny all ICMP IPv4 traffic. Okay, by using the private IP address /32. So let's go back to the network ACLs, go back to the inbound rules, edit inbound rules, add a new rule. Let's name the new rule 101, and then what should we do? Say it should deny all ICMP. So let's go back, all ICMP IPv4, and this should be our private, this should be this. Okay, the test instance, you should copy this, the private IP address, go back here, paste that one here, okay, /32. Then it should deny them, right? So let's save changes. Let's do the same for the outbound rules. Edit, add rule 101, then all ICMP before. Let's see, yes. And then the private IP address /32, and then it should deny it. Let's save the changes. Okay, so let's go back to the instructions. In the private instance terminal window, the ping command should stop responding. So this will stop. Okay, it's still running, but it will stop since we've denied the access. All right, so let's go down. You have now denied traffic from the private subnet to the test instance as shown in the following diagram. All right, so let's scroll down. Let's answer some questions about the lab. So you should go to access the multiple choice questions and then answer question 1 to 6. So let's go to details, then show. Let's scroll down to access the multiple choice question. Okay, so question 1 is, what is the purpose of the internet gateway in the public subnet? So anything related to internet gateway should be something related to the internet, right? Okay, so let's see. So this is, we are not seeing any internet here, so it should be allow instances in the public subnet with public IP address to communicate with the internet. So is this answer? Let's submit it. Let's go back. Question 2. What allows the instance in the private subnet to connect to the internet so that it can download updates? Here, of course, is the NAT gateway. Alright, so let's select it. Let's go back. Can the instance in the private subnet be accessed directly from the internet? No, no, no. For the private subnet, no, it cannot access directly from the internet. So let's select no and submit the answer. Let's go back. Why do you use two different key pairs to access the private instance and the busting host? Let's see. Yes, it separates keys to separate key pairs. Separate key pairs could help reduce the impact of compromised busting hosts. That is the answer. So select this. Let's go back. Question 5. Can the busting host use ping and then get a reply from the instance in the private subnet? No, no, I don't think so. So let's go back. Which security group rules allow the private EC2 instance to receive the return traffic when it pings the test instance? It's actually outbound on traffic and then inbound on test. Yes, it's this one. It's outbound on private and inbound on test. Let's submit it. Let's go back and see. We can choose to close this. Let's come down. Okay, so they said when you are done, submit your work. So let's submit our work and then look at the marks we have. So let's wait a while for it to finish recording the grade. Okay, so submission recorded. Let's see. This will take some time. Maximum 1 minute, right? So let's wait for the results. We have 51 out of 56. Let's see what's wrong. Is this network ACL does not exist? Okay, so let's go back to the network ACL. Don't close the lab. Okay, don't close any of the tab. Let's go to network ACL. We have to associate the network ACL to the private subnet. Let's check whether the route table has been associated first. So let's see the private route table, the association. Yes, it has been associated with the private subnet. Let's go back to the network ACLs to and check whether it has been associated. So let's go to subnet association. It hasn't been associated. So let's edit subnet association and then associate it to the private subnet. Okay, and then save changes. Yes, now we should get everything. Let's submit the work and wait a while, then see. So the submission is being recorded. All right, and let's wait a while to see. And now you have seen that we've gotten everything right. Okay, 56 out of 56. All right, so thank you very much for